Yeah, good day viewers. Hope you've been good. Yet again is Access Point Academy video lecture series, and in our video today we want to unravel equilibrium quantities and equilibrium constant calculations. That is calculations that has to do with equilibrium quantities. Okay, so we want to learn calculation of equilibrium constant, that is the symbol for equilibrium constant, Kc, from equilibrium reaction. So we have the first question here. And what does the question says? We have hydrogen reacting with iodine in a reversible reaction. This is the chemical equation for the reaction. This is hydrogen gas reacting with iodine in a reversible reaction to give 2 molecules of hydrogen iodide. So now the question continues and says 0.450 mole of hydrogen and 0.3 mole of iodine were mixed together in a container of volume 1 dm cube. So at equilibrium, 0.060 moles of iodine were present. Now we are asked to calculate the equilibrium concentration of iodine and also hydrogen iodide. And the second part of the question says we should calculate the equilibrium constant Kc. So how do we do that? We need to solve intelligently and accurately. So solution to that question. Now, very essential, we have to write out the equation as it is given in the question, and the equation is hydrogen reacting with iodine, okay, in a reversible reaction to give 2 molecules of hydrogen iodide. Is an homogeneous equation because all are in gaseous states. Okay, now very essential, we need to write out the mole ratios. It is observed and seen that 1 mole of hydrogen reacted with 1 mole of iodine to give 2 moles of hydrogen iodide in a balanced chemical equation. Now, very important, to solve a question that has to do with equilibrium quantity, we make use of this format: ICE. I stands for the initial mole, C stands for change, while E stands for the equilibrium mole. So ICE is what we're going to work with to solve intelligently. So now, firstly, we write the initial mole. Initial, the unit is mole. Okay, so the initial mole given in the question said 0.45 mole of hydrogen. So under hydrogen, we need to write 0.45 in mole. Okay, 0.450 is accepted. So now the initial mole for iodine, which is 0.300. Okay, so we don't have that, we are not given the initial mole for hydrogen iodide, so we can write that as dash or 0. Now next is to write the third thing in this code is the equilibrium. Okay, because that is what we given next. Equilibrium also units in mole. Now as the question proceeds, it says at equilibrium 0.06 moles of iodine was present. So at equilibrium 0.06 moles of iodine. So we have to write the equilibrium concentration of iodine, which is 0.06 mole. Okay, so now we don't know the value for the equilibrium mole of hydrogen, neither do we know the value for the equilibrium mole for hydrogen iodide. So but meanwhile we can easily calculate that. Now to get the change in mole, okay, to get the change, which is also mole, now we have to subtract 0.06 from 0.3. So and when we do that, so we got 0.24. So you subtract this from this, Okay, so that is the change in mole for iodine. Meanwhile, because the mole ratio of hydrogen to iodine is 1:1 and the change in mole for iodine is 0.24, therefore the change in mole for hydrogen will also be 0.24 in mole as well. However, now we compare this with this. We have 2 mole of hydrogen iodide in the mole ratio. So definitely, to get the change in mole for hydrogen iodide, we have to multiply this by 2. And on multiplying by 2, so we got 0.48. So now we can easily calculate the change equilibrium mole for hydrogen. Okay, so that will be 0.45 minus 0.24. So, and I'm subtracting that, the equilibrium mole for hydrogen is 0.21 effortlessly, and this 0 minus 0.48, this minus this, that will be 0.48. So therefore it is seen that the equilibrium mole, the equilibrium concentration in mole for I2, in mole for I2, for hydrogen is 0.21, then for I2 is this, and that's for hydrogen iodide is this. But meanwhile, the question says calculate the equilibrium concentration of I2 and IHI. So now to do that, we should always remember that concentration is equal to number of mole. Okay, that is equilibrium mole now. For conveniency, equilibrium concentration is equals equilibrium mole divided by volume. Okay, a volume has been given in question to be 1 dm cube. So now we can calculate the equilibrium concentration for each of those species at the reactant and the product site. So now for H2, its own equilibrium mole, that is, this is equilibrium concentration, so the equilibrium mole for H2 is 0.21. So we divide it by 1, so therefore we get the concentration, equilibrium concentration of H2 rather, hydrogen, will be 0.21 mole per dm cube. Now we do similar thing for iodine. So iodine, that is the equilibrium concentration for iodine, and that will be the equilibrium mole 0.06 divided by 1, and that is also going to be 0.06 mole per dm cube. Okay, so now we do similar thing for hydrogen iodide. Okay, so now its own equilibrium mole is 0.48. So we divide by 1 as well, which is the volume. The 1 is the volume. So its own equilibrium concentration, therefore, will also be 0.48 excuse me, mole per dm cube. Okay, so now after we've gotten the equilibrium concentration, but in question we are asked to find the equilibrium concentration of iodine, which is this, and for hydrogen iodide, which we've also done, and this is it here. Now that is the first part of the question. That is the A part of the question. Now the B part, we are asked to calculate the equilibrium constant Kc. So how do we do that? Now to calculate the equilibrium constant, that will be the equilibrium concentration of the right hand side, okay, divided by the species of the concentration of the left hand side. So for that we have that is HI to the power of 2 according to the law of mass action, then divided by the equilibrium concentration of hydrogen multiplied by the equilibrium concentration of iodine. So we have those values. This is 0.4 for hydrogen iodide, 0.48 square, okay, that is mole per dm cube, everything also squared because of these two, divided by the equilibrium concentration of hydrogen, which was 0.21 mole per dm cube, multiplied by the equilibrium concentration of iodine, that is 0.06 mole per dm cube. Now let's first justify the units. Now this we cancel out one of this, and this we cancel out this, so our equation is going to be unitless. Now therefore our answer is going to be unitless precisely. So now 0.48 square, when we calculated that was 0.2304 divided by 2.1 multiplied by 0.06, that is 0.0126. So now on dividing this, okay, that will be 18.3, okay, no units. So that is how to go about that. Okay, that is the equilibrium concentration. Thank you.